Good day. I am Vernon Manahan and my groupmates are Sherwin Espinosa, Joshua Milan, Azul Jethro and we are here to discuss the biogeochemical cycles, the anthropogenic effects, invasive species, and epigenetics.
We all know that the air is a mixture of gases. The atmosphere comprises several gases including nitrogen, oxygen, argon, and other trace gases. It plays a vital role in most living things on Earth. So before we dig deeper into oxygen and its cycle, we must first understand one important concept, and that is the biogeochemical cycle. Energy flows directly across ecosystems, entering as sunlight and leaving as heat transfer between trophic levels. The substance that makes up living creatures is preserved and recycled rather than moving through an environment. The six most common elements in organic molecules are carbon, nitrogen, hydrogen, oxygen, phosphorus, and sulfur, and they take a variety of chemical forms. Each biogeochemical cycle can be considered a reservoir. A larger one is a slow-moving, usually abiotic portion. In contrast, a smaller reservoir pool is a more active portion concerned with the rapid exchange between an ecosystem's biotic and abiotic aspects. The cycling of these elements is interconnected. The flow of water, for example, is essential for the leaching of nitrogen and phosphate into rivers, lakes, and oceans. Furthermore, the sea itself is a significant reservoir for carbon. Thus, mineral nutrients are cycled across the whole biosphere either swiftly or slowly, from one living creature to another and between the biotic and abiotic worlds.
Now that we know about the oxygen cycle, let me tell you about the anthropogenic or man-made factors that contribute to the Earth's air pollution. While there exists what is called natural air pollution caused by natural events, such as hurricanes and volcanic eruptions, man-made air pollution as a result of human activities are what we can consider to be primarily responsible for the pollution that we experience, that ultimately contribute to things like respiratory diseases, acid rain, and especially global warming. Factor number 1, burning of fossil fuels. In a 2018 study, results showed that about 89% of the world's global carbon dioxide emissions came from the fossil fuel burning industry, making it the biggest contributor to pollution on Earth. Burning coal, gases emitted from vehicles, releases all sorts of gases and chemicals into the atmosphere, which causes air pollution, such as smog. Factor number 2, agricultural activities. Farms are a major source of air pollution. Agricultural air pollution comes mainly in the form of ammonia, which enters the air as a gas from heavily fertilized fields and livestock waste. It then combines with pollutants in combustion, such as nitrogen oxides and sulfates from vehicles, power plants, and industrial processes, creating tiny solid particles called aerosols, which can penetrate deep into the lungs and cause heart and pulmonary diseases. Factor number 3, mining operations. Particulate matter transported by the wind as a result of excavations, blasting, and transportation of materials stand as large sources of air pollution in the mining industry. This can then generate a substantial quantity of airborne respirable aerosols, which can lead to the development of respiratory diseases.
In this part, I will now discuss the invasive species in the air. There are many questions about this certain topic, and I will answer each of the most important questions briefly. So, first and foremost, what are invasive species? According to the National Geographic, an invasive species is an organism that is not indigenous or native to a particular area. Invasive species can cause great economic and environmental harm to the new area. It can also harm natural resources in an ecosystem as well as threaten human use of these resources. Now, the other question that we want to know is how do we differ or observe a species for it to be considered invasive? We can consider a species invasive if it is capable of causing extinctions of native plants and animals, reducing biodiversity, competing with native organisms for limited resources, and altering habitats. Basically speaking, To be invasive, a species must adapt to the new area easily. It must reproduce quickly, it must harm property, the economy, or the native plants and animals of the region. Now, we proceed to the controversial question. Are we humans invasive? Since our topic focuses on the air, the answer to the question is yes. Why? Because us humans are causing the mentioned phenomena. We are causing air pollution. We burn fossil fuels. The transportation that we use emits air pollutants. Our continuous open burning of garbage waste, construction and demolition, the use of chemical and synthetic products, and many more. Now, you may be asking, why did I solely focus on us humans being invasive and not on others? Because it is us that can put a stop to this. We should focus and be aware on what we can do to help our oxygen cycle be nurtured and avoid the unwanted disaster air.
Now I will discuss what epigenetics is and how the environment affects and influences it. But first, what is epigenetics? Before I answer, we must know that genes play a vital part of our cells. It is the basic physical and functional unit of heredity. The study on how behaviors and environment can cause changes that affect the way our genes work is called epigenetics. Yes, epigenetics is the study of how outside changes or actions affect our genes. In a study conducted by Shaw 2008, it is stated that environmental cues such as hypoxia, which is a state in which oxygen is not available in sufficient amounts at the tissue level, can affect gene expression and trigger cancer development. This shows that different oxygen levels can affect how our genes work. There are organisms such as deep-sea creatures that have adapted to low-level oxygen areas in order to survive, causing changes in gene expression. Some might even call this change evolution. The type of environment an organism or a life form is can drastically change how it lives and evolves. This just shows how great of a factor our environment is when it comes to our genes. And that is all for our discussion on the oxygen cycle. We hope that you all learned something from our video. Thank you all for watching and God bless.